All right, CEA students, Mr. Voigt here. We're back. We did the end reactions for this beam last time using formulas. Now we're going to go ahead and do the bending moment, and that is the maximum moment. On our charts, that's where we have the big um, curve at the bottom, or we show where the bending moment is. This stuff, so on this particular beam, remember we have a chart down here, and it's going to go like this, like that for our end reactions. And on this particular one, we're going to have uh, for our max moment, it's going to be the height of this. Wherever this crosses this line will be the maximum moment down on this chart. So you remember all that. Again, purpose for this is not necessarily to review all that, but just to remind you what we're doing. So we're finding the max moment for down below. Before, we would find our max moment by finding the areas on our other diagram. Remember, I shouldn't have erased that, right? We went like this, and then that line was going here. Remember, we found the areas of these different things and added them together, and that would give us our max moment down below. And then we would come down here, we'd find the area of everything to the left of this, and that would give us our max, or our moment for that area. And then we would find, excluding the little part here, and we would find this one, and then we would draw an arc that goes between them. Well, instead of having to do that, we can now use formulas to do this. Okay, I told you the other day that we weren't going to have to do this, and I was mistaken. I don't know. Sometimes my brain gets going in class. You guys should know this by now. And I'm thinking about other things. You do not ever have to make this chart again, but we do have to figure out these numbers down here. Okay, we do have to figure out these numbers down here using the formulas. So I'm going to expect you to be able to find the max moment without drawing a chart. So you're just, as you can see, the chart drawing is going to be done using Beam Guru. Okay, so I want you to, after you get these numbers, you type your things into Beam Guru and you print off a chart. Okay, so max moment is pretty simple. Before, you should know, we used to find our reactions, we used this beam because we had a uniform load, and we did this one twice because we had two concentrated loads at non-symmetrical places. So that's what we're going to do again, except we're going to use the moment, okay, the moment max formula for this. So right now it's WL squared divided by 8 for our uniform load. So right here I have uniform. We're going to go WL squared divided by 8. So our W is 160 times 18 squared. And I'm just going to go ahead and type 18 times 18. That's 324. I'm just going to write that number in there, divided by 8. That's 160. And then I'm just going to go ahead and do this out. So 160 times 324 equals 51,840 divided by 8. Divided by 8 equals, so 6,480. And remember, max moment is always in foot-pounds. And again, I don't want to go back and go through why it's foot-pounds. Okay, but it is. So that takes care of your uniform load. And in the end, as you can guess, I wrote over here, we're going to add our max moment for our uniform load, our max moment for our first concentrated load, and our second concentrated load all up, and we'll get our maximum moment over here. So let's use our second formula. Down here it says, for this, our max moment is our P, which would be our load, times A times B divided by L. So we're going to go ahead and write that in here. P, A, B, L. It's going to be the same down here, right? It's just going to be different numbers. Our P for 1 is 650 pounds. I can show you. Our P is 650. Our A is 5, and our B is 13, right? Or, yeah, 13. 7 plus 6 is 13. So our A is 5 and 13. For this one, our P is 800, our A is 12, and our B is 6. So they're slightly different. This is going to be times 5 times 13 divided by 18. This is going to be 800 times 12 times 6 divided by 18. Okay, so all I got to do is type those in here. So 650 times 5 times 13 equals 42,250 divided by 18 is 2,347.22. 2,347.22 foot-pounds. Okay, we're going to do the next one. 800 times 12 times 6 equals 57,600 divided by 18 divided by 18, 3,200 foot-pounds. Okay, so our uniform load is 6,480 pound. No, I can't write pound. It's foot-pounds. We're not going to, I guess I should write it in here. This one is 2,347.22. And this one is 3,200. Okay, so let's add those up. 6,480 plus 2,347.22 plus 3,200. So my moment max is 12,027.22 foot-pounds. Okay, that's what you need. So what'll happen is I want you to figure this out. Basically, when you type things into Beam Guru, it's going to spit all these numbers back at you. Okay, so theoretically, you wouldn't need to do any of this. But again, we're taking baby steps, right? You do the algebra method, you do this method. I am not making you redraw this down here, so be thankful. I'm allowing you to type it into Beam Guru, let it spit it out. What I would do if I was you is make sure the Beam Guru numbers on there match your numbers here. They should. Okay, so that's how you do this. So please, you should have followed along with this. I have given you a second practice where you can do both your end reactions and your bending moment by practicing these numbers. I will also then have a key that you can check your answers with. Okay, remember, print out your Beam Guru, practice putting the information into Beam Guru and printing it out as well. All right, thanks.